All right, so we're on 3.4 quadratic inequalities. Our objectives here are to understand basic concepts about quadratic inequalities, solve quadratic inequalities graphically, and solve quadratic inequalities symbolically, which just means algebraically. So inequalities. An inequality is those are our greater than or equal to, less than, or less than or equal to symbols. Those are our inequalities. Equality symbols are the ones that are equal sign or telling that it's not equal to something. Okay, so just making sure we understand the symbols that are being used. All right. When you are looking for solutions of inequality, it is pretty straightforward. It's pretty straightforward. So when I'm looking here, it says 1 minus x squared is less than 0. What that is asking is when am my function below the x-axis, right? Because you're looking for y values that are less than 0. So your y values, that means that your y values are negative. Does that make sense? So if I'm looking for less than 0, that means I need negative y's, which means that I'm looking for when I am below x-axis. That's simply all it's asking you. So for part A, it's asking when are you below the x-axis? So I'm below the x-axis from here to, oh, pretend that I highlighted that correctly, to here, right? So those are my solutions. How you write the solution is what's important here. So when I write my solution, I'm saying starting from left to right, because you write your solution reading from left to right. My function starts at negative infinity, and it goes all the way up to negative 1. That's part 1. And, horrible and, this also occurs from 1 to positive infinity, because as I go forever to the right, that is positive infinity. So from 1 to positive infinity. So that's writing in terms of an interval. Notice that I'm using parentheses. When you have strictly less than or strictly greater than or infinity, you're going to always use parentheses. When it says less than or equal to or greater than or equal to, you're going to use brackets. Okay. The other way that you can represent this is as an inequality answer as well. So here, when I'm saying negative infinity to negative 1, I'm saying that my x values are less than negative 1. The way that I remember this is if you look at the inequality symbol, I'm heading left, like the little symbol saying your x's are going to the left. Okay. And the other way to write 1 to infinity would be your x's are greater than 1. So your x values are heading to the right. Okay. So now if you look at example B says 1 minus x squared is greater than 0. So if I'm greater than 0, that means that my outputs are positive. So we're looking for positive y's, right? When do I have positive y values? Well, you're going to have positive y values when you are above the x-axis, right? So when we're above the x-axis is when I'm going to have those positive y values. So when I come over here, I'm going to highlight where am I positive? Well, I'm above the x-axis from here to here. So for part B, my solution would be from negative 1 to 1. Or I would write it as an inequality. X is less than 1, but greater than negative 1. Okay. How do you feel about solving an inequality from a graph? Okay. So notice that for this graph, when we saw the inequality, our right side was 0, right? So in order for this to work, your right side has to be equal to 0. So in order for us to continually do this, your right side has to equal 0. So the right side of the inequality has to equal 0. In order for you to simply just be looking above and below the x-axis. Okay, so from this example, we know that if I am less than 0, we're looking below. And if I am greater than 0, we're looking above. All right, questions so far? None? Any points of confusion? Do we not have questions because we understand, or we don't have questions because we just don't even know what to ask? Because we understand? Oh, perfect. Then that is awesome sauce. All right, so we're going to go on to the next one. The next example that we're going to look at is going to be an example with your when your graph is not your graph, your equation is not equal to 0. Yeah, sorry. I had a little brain fart there. When your equation is not equal to 0, and we're going to analyze it from there, okay? I was fixing another piece of the notes to make sure that that would go smoothly when I get to it. I realized that I didn't like how it looked. Okay, we're going to move on. So notice here, when we're looking at this graph, we can see that 5 minus 4x is less than x squared, right? Before we can get started, we want to make sure that our right side is what? 0. And is our right side currently 0? Okay. Now, this is the little hiccup here is that if I try to make the right side 0, what's going to end up happening is that the direction of my graph is going to change, correct? Because the only way to make the right side 0 would be to subtract x squared. Currently, do we have a graph of a negative parabola? No, we have the graph of a positive parabola. Because we have the graph of a positive parabola, making our right side equal to 0 is not going to be the move to make. Does that make sense? So we're going to move everything on the left to the right so that our equation is going to stay true to what our graph is. Make sense? All right, so we're subtracting 5 and we're adding 4x. Because in order to make one side equal to 0, you have to do inverse operations of addition and subtraction, right? If I divide, that is, well, it doesn't work mathematically, but dividing by something is going to make it a 1, not a 0, correct? All right, so when I do this, I'm now left with 0 is less than x squared plus 4x minus 5. Okay, what I like to call this here is the mirror effect, okay? By mirror effect, all we're going to do is just reflect. So you know how when you look in a mirror, it's the same thing, but written backwards? Okay, same central thing here is we're going to do the mirror. We're going to mirror this. So when we mirror this, everything is going to be the same. So we're going to have x squared plus, I forgot that's my like no weird writing zone, and I don't know why. And it still has to be greater than 0. So notice that the mouth, quote unquote, the mouth of my inequality is still facing my expression, right? My function. All right. So now is my 0 on the right? Yes. So when I read this, I can still read it as x squared plus 4x minus 5 is greater than 0 because I'm looking at it, x squared plus 4x minus 5 being greater than 0. I'm looking for when is my function above the x-axis. Okay. So we're above the x-axis. All right, sorry. So notice that I use this U symbol. This U symbol means or mathematically, okay? So it means that I am above the x-axis from -infinity to -5, or I'm above the x-axis from 1 to infinity, right? So that's writing an interval notation. If you were to write it using inequalities, you're saying that x is less than -5 or x is greater than 1. Okay. At this point in college algebra, you need to be comfortable going between interval notation and inequality notation. And you need to be comfortable reading the two. So when you see this symbol, all right. So our next example, we're going to not have the graph. We're going to create the graph ourselves. Okay. So we're going to start off by creating the graph ourselves. So here we have 5x squared plus 14x minus 3 equals 0. Okay. Notice that this is not an inequality, but an equation. And the reason why it's an equation is because there's a equal sign, right? Yes, we agree. All right, so because there's an equal sign, that lets us know that we do not have an inequality. For this, this is what 3.3 was about, was being able to solve quadratic equations, right? So we learned you can do quadratic formula, you can solve by factoring, you can solve by completing the square. You have various ways of solving this, correct? Okay, so we're going to go through, I'm probably going to do a variation of some stuff. So um, solving this, because it's a leading coefficient greater than 1, I can't just do simple factoring, asking myself what multiplies to give me my C term, but adds to give me my B term, right? I have to do a little bit more. So some of your teachers may have taught you in the past bottoms up or some other things. I just don't know. But all I can tell you is that I stick to grouping and I stick to box method, any of those to fill it in. So I'm going to model it with the box method just as far as organization. So with the box method, what it is, it helps you factor with organization. Okay. So in the first box is always going to be your first term. So our first term is 5x squared. And the bottom box is going to be your last term, and our last term is -3. Do we all agree? Okay, the middle is what's unique. Your middle comes from finding the factors of the product of your A and your C. So my A and my C currently is 5x squared and -3. So you're going to ask yourself what multiplies to give you 5x squared times 3, which is 15x squared. So you're looking for what multiplies to give you this, but adds to give you your middle term because you're replacing the 14x. So what two numbers would multiply to give me 15x squared, but add to give me 14x? There we go. You would have 15x and -1x. And those are the numbers that go in the box. Once the numbers are in the box, and this is just a matter of greatest common factor. What is the greatest common factor of each row and each column? So of each row and each column, what is your greatest common factor? So my first row, my greatest common factor is 5x because I can divide each box by 5x, right? And my second row, I'm sorry, my greatest common factor would be -1. If your outside box is negative, then your GCF is going to be negative. Just like when you're factoring a binomial, if the leading coefficient is negative, then the GCF is negative, okay? In your first column, we have 5x squared minus 1x. So in our first column, our GCF between 5 and 1 is just going to be 1. And x squared and x is going to be x. And our last column between 15x and -3, our GCF is going to be +3. And you can check yourself so that you know that you did it correct. You can go back and see if you multiply what's on the outside, does it create what's on the inside? Does that make sense? So as I do a mental check to make sure I did it correctly, I have 5x times 1x. Does that make 5x squared? Yes. I have 5x times 3. Does that make 15x? Yes. I have 1x times -1. Does that make -1x? Yes. I have 3 times -1. Does that make -3? Yes. So you can check your box work, which is why a lot of times the box is a friendlier form of factoring. Okay. There's still quadratic formula. There's still your option of factor by grouping. But if you struggle with either one of those and it's a factorable problem, the box method tends to help it make it a little more organized. Okay. So from there, you now know your factors. So you now know that you have 5x minus 1 times x plus 3 equals 0. Because you have this information, you now know where your x-intercepts are lying. So my x-intercepts are going to be at x equals. What would I need to do to get 5x, x by itself with 5x minus 1? Well, I'm adding 1 and dividing 5, right? So I know x equals 1/5. On x plus 3 to get x by itself equal to 0, I would have to subtract 3. So my x would be at -3. So I know that I have x-intercept at -3 and at 1/5. My little lines are really tiny, so I'm going to, let me see how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I wonder if I can count by 1, 2, 3, 4. This is going to be -1, 1, 2, 3, 4. This is going to be -2. No, it won't let me make out that far. It's just going to be a tiny graph. I was trying to make my graph a little bit bigger. I'll just count by halves. I could do, yeah, I could do thirds. -1, 1, 2, 3, 1, 2, 3, -2, 1, 2, 3, -3. All right, so I'm gonna put my -3 there. Yes, Mr. Hughes. You're gonna mute it yourself. Oh, you're good? Oh. All right, so then we have 1, 2, 3, 1, 1, 2, 3, 2, 1, 2, 3, 3. All right, so now we are at graphing these points. So here is my -3, and then my 1/5 is going to be 2. This is halfway between the two. Okay, it's just gonna be a guesstimation, guys. It's not gonna be perfect. So it's gonna be somewhere in there, right? I know that that's 1/5, okay? The other thing that we know from this equation is our x-intercept. Our x-intercept is at -3. Your x-intercept is always given to you. It is your constant in your form. So our x-intercept is at -3. So from here, 1, 2, 3, -1, 1, 2, 3, -2, 1, 2, 3. Thank you, -3. I can kind of have a idea of what my function is doing. So I know that because it's a positive, it's coming down, it's going down somewhere. I'm going to have to come back up through. Oh, that did not go through my x-intercept. It is really hard drawing in PowerPoint with this writing pad. I swear. One day they're going to be friends, or I'm going to find a better writing thing. Okay. Pretend that is the most curvaceous parabola you've ever seen. Okay. All I need to know is where those values are taking place. Does that make sense? Where am I above and below the x-axis? Okay. So here's my graph. Here's my beautiful graph drawn for you. I now have an idea of where I'm at. So this would be it. If it's just solving, all I'm looking for is the x-intercepts. I have solved, I have found. That's what equal is saying, okay? Now, the next is that we're going to further elaborate on this and find where we are using inequality. So we're going to go from an equation to an inequality, but we're still using the same function. All right, so going from the equation to the inequality, I'm going to do my little sketchy sketch really quick. These are going to just be all estimated values because we know what the real values are, and we're going to pretend that Miss Jones is a great drawer. Like, she's awesome. Yeah. Not drawing a sketch. What is super important is what my x-intercepts, okay? Because your x-intercepts is where your graph is being divided between above and below the x-axis, right? That's what's the most important part, is where is my x-intercept. So when I look here, we're going to create a sign chart. So on that sign chart, I have -3, and I have positive 1/5. From our graph, we know that the values to the left of -3, those are positive y's, right? The values between -3 and 1/5, those are negative y's, right? And then the values to the right of 1/5 are going to be positive y's. Agree? That's what we need to know to solve this inequality. Okay? So looking at my inequality, it says that I am less than 0, right? If I am less than 0, I'm looking for what type of y values? It's not a trick question. I'm looking for what kind of y values? Negative y values. We need negative y values. My negative y values are between where and where? -3 and 1/5. So my solution is simply from -3 to 1/5. Or it can be written as x is greater than -3, but less than 1/5. Does that make sense? Okay. Okay. And again, this was less than 0 because I'm less than 0. I want positive y values. All right. So now we're going to do it. Our next one. Our next one is asking us for greater than 0, right? So if I'm looking for greater than 0 values, I'm not even going to draw the sketch. I'm going to just use my sign chart. For my sign chart, that's where my x-intercepts are going, right? My x-intercepts, we have -3 and we have 1/5. We know that we have positive y's to the left of -3. We have negative y's between -3 and 1/5. And we have positive y's to the right of 1/5. Because it says I want to know when 5x squared plus 14x minus 3 is greater than 0, I'm looking for what kind of y values? Positive y values. So I have positive y values in two locations, right? I have positive y values to the left of -3 and to the right of 1/5. So my solution set would be from -infinity, because if I'm going forever to the left, that means my x values start at -infinity, right? So I'm going from -infinity to -3. Or I can also go from 1/5 all the way up to positive infinity. Okay. When I write these as inequalities, I'm saying that x's are less than -3 or my x's are greater than 1/5. Which makes sense when you're looking at the number line, right? Because I'm saying either going forever to the left or forever to the right. Okay. How do we feel about solving and setting up an inequality? Okay. So let's recap really quick. So initially we started off inequalities just from the graph, right? We didn't have to find anything. It gave us the graph. And from the graph, I'm just now making sure it's above and below, right? Then we moved into, okay, here's your inequality from a graph, but your equation itself is not set to 0, right? In order to get it set to 0, I had to follow the pattern of my numbers, right? If it's a positive, then I need to make sure that my leading term stayed positive. If it was negative, then I could have, moved that bad boy around. But as I'm reading this, I made sure that I made this 0. I stayed true to the graph that was given, and then I mirrored, right? After I mirrored, I was able to say, okay, I'm looking for when it's greater than 0, which is still 0 is less than this, means the same thing as this being greater than 0. And so I was looking for specifically where am I above the x-axis, and we found our above the x-axis pieces, correct? All right, then we moved into, okay, you're now given the equation, but with no graph, okay? In order to solve an inequality without a graph, you have to first find out where the x-intercepts lie, which is why we should think of it as an equation first. Does that make sense? So we find out where our x-intercepts lie, and so you either can do that by factoring or by using the quadratic formula. Does it matter which one you use? No, okay? If you're more comfortable doing x equals -b plus or minus square root of b squared minus 4ac divided by 2a, hey, go for it, okay? But if you are like, oh, this was a little faster than using quadratic formula, if I could remember the process, right? I found my x-intercepts, and from finding my x-intercepts, I can then set up and create a sign chart. From that sign chart, I'm determining where things are positive. By things, I mean y's are positive and where y's are negative. Okay? And then we can go from there. I mean, one of y'all got to do it. All right? From there, we then continued on and reiterated the fact what's above and below. Any questions, comments, or concerns about any of that process? Okay. All right. I'm trying to make sure that we're comfortable because there's not going to be a second test for chapter 3. So if you have questions or points of confusion, the prime time to ask is now during the lesson and on Friday during study hall. Okay. Because there's not going to be a second attempt on chapter 3. Okay. All right. So the quadratic inequality we have here is 1/9 x squared plus 11/3 x, which is less than or equal to 200, gives a stopping distance for a car traveling at x miles per hour on wet level pavement. Solve this inequality to determine the safe speed on a curve where a driver can see the road ahead at most 200 feet. What might be a safe speed limit for this curve? Okay. So we're looking for a safe speed limit for this person to travel on. All right. So I'm going to write it so that we can work it. So we have 1/9 x squared plus 11/3 x is less than or equal to 200. So the first thing that we have to address is that, is my right side set to 0? No. So what do I need to do to get my right side set equal to 0? Subtract. So I'm going to subtract 200 from both sides. This is now going to make this side 0, and I'm going to be left with 1/9 x squared plus 11/3 x minus 200 is less than or equal to 0. Okay? Next, a lot of you freak out about fractions, right? You're like, oh no, there's a fraction. We've talked about this before. When you have a fraction and you don't want it or you don't like it or it bothers you, you would use the LCD, the least common denominator between your two fractions in order to get rid of the fractions. So for this problem, our LCD between 9 and 3, our least common denominator would be 9, right? 9 is the smallest number that 9 and 3 can both divide into. Does that make sense? The purpose of that is because you can multiply everything on the left by 9 and everything on the right by 9, and that's going to eliminate your fraction. Okay? So 9 times 1/9 is 9, because 9 times 1 is 9. 9 divided by 9 is 1. Plus, now we're doing 9 times 11/3. So 9 times 11 is 99. 99 divided by 3 is 33, right? So that becomes 33x. And then 9 times 200 is just simply 1800. And anything times 0 is 0. Oh my gosh, there's no fraction. Oh, we survived. Okay. So if the fraction was really a big deal for you, then you can get rid of it. Does that make sense? Okay. In the bottom. Okay. So at this point, you have the choice to try factoring, use a quadratic formula. You have the choice to graph and analyze the graph, whichever thing makes your heart happy. Does that make sense? You've done your part. So I'm going to model using the calculator because I've yet to do a problem with us doing it in the calculator. Does that make sense? I'm going to open my handy dandy calculator. Sylvie. Her name is Sylvie. Okay. You're welcome. Here we go. So we're going to put into Sylvie. I'm going to reset Sylvie. To reset my calculator, second plus 712. All right. I'm going to go to y equals, and I'm going to put in my equation. I have x squared plus 33x minus 1800. Okay. This minus 1800 lets me know that my window is going to have to change, right? Because are you going to see minus 1800 on this calculator automatically? No, these are pretty big numbers. So I'm going to go ahead and change my window. By changing your window, that just means that you understand you are setting it to larger values. I'm just going to be obnoxious right now and start off with negative 100, positive 100. And again, if you don't care about the little tick marks, then leave this part alone. I hate seeing a bunch of tick marks, so I'm going to change that to 10. And then on my y min, I'm going to switch it to negative 2,000 because right now my x-intercept is at negative 1,800, right? So if my x-intercept is at 1,800, negative 1,800, I clearly have to go way higher. I'm going to be even more obnoxious, put you at 2,000, and I'm going to put you at 1,000. Okay? This is an exercise of math common sense. Does that make sense? So you have to use a little bit of like, okay, logic tells me I may need to go bigger. I may not be able to see my graph if I don't go bigger. Does that make sense? So by expanding my window before I even get there, I'm like, oh my gosh, it didn't work. I did something wrong. I looked at the numbers that I had and realized there's no way this is fitting between a 10 by 10, right? And so I changed it so that I could see the values that I need to see. Can I clearly see my x-intercepts? Yes, I can. And those are the values that are important is where are my x-intercepts? Where am I crossing the x-axis? Because that's going to let me know where I am greater than and above, like greater than or less than. All right, so using the calculator to find those values, I'm hitting second trace, and I'm looking for my zeros. You see where it says 0? So I'm going to press 2 for 0. Here's my little spider. My spider is going to crawl. I like to make them start from the left because it's going to already tell you to go to the left bound. Left bound just means that you need to be above the x-axis, or below the x-axis because you have to change that direction so that you can show by definition that this is a 0. So I'm above, then I'm going to go below, and it's going to tell me that I have an x-intercept at negative 62.022. So we know that we have an x at negative 62.022. So that's one of my x-axes. Okay, with me? All right, then the next one, we're going to do the next side. So you can go ahead and move your spider if you want to the next side, but it moves slowly unless you're tracing. See how slow that thing is moving? So I'm going to hit second trace, and I'm going to find my second 0. Here's my spider. He's going to crawl to the other side. Go, 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 Power Ranger. He's going, he's going. All right, I'm below the x-axis, and I'm going to go above the x-axis because we read our graphs from left to right. Hit enter. It's like, here's your 0. Our next 0 is at 29. So we're at x equals 29.022. All right. So we have two values here. These two values are based off of the original problem, correct? The original problem is asking us for a safe distance of speed. Can you have a negative speed? You can't. So when we're answering this, we have to keep in mind that this is a real world problem. So we have to make sure that it matches the real world solutions. Does that make sense? So it says that if you are speeding at going a certain speed, what is a safe distance you should be slowing your car down? And when we set up our inequality, we ended up with x squared plus 33x minus 1,800 is less than or equal to 0. And because it's less than or equal to 0, we are looking to see when we are below the x-axis, right? We are below the x-axis from our first x-intercept here at negative 62 to our second intercept here at positive 29. Agreed? Okay, because I cannot have a negative speed, right? That means that these values don't matter. It doesn't start mattering until I'm at 0. Does that make sense? Am I making sense? Okay. So that when I am at 0 and up to here is what matters. So from 0 to 29.022, that would be my answer. Not from the negative because that doesn't pertain to the real world problem. Okay. That's what we have to use again, that math common sense. Okay. So yes, I am completely below the x-axis from here to here. But because I'm driving and I'm analyzing my speed and my distance, I cannot account for the parts that are negative. Make sense? Okay. So coming up here, solve this inequality, determine the safe speeds on a curve when a driver can see the road ahead for at most 200 feet. What might be a safe speed limit for this curve? Well, it says 0. So starting at 0 and then going up to 29.02. So our solution set would be for this problem is that x would have to be less than or equal to 29.02 or greater than 0. We are going to say greater than 0 because should you be stopping on this curve? No. Have you noticed that when we were traveling around curves that they're mainly 30 or less miles per hour? Have y'all been on Lakeshore? Yeah, it drops down, right? Because you're coming around a huge curve. Real life stuff. Oh my gosh, math in real world. Crazy. Okay, how do we feel? Okay. All right, so we always have to tie in a real world problem, and I just want to make sure that we're comfortable with the real world problem. Cool? Okay. All right, so just recapping our steps when we are solving. Okay. So when we're solving, step 1 is that we're going to rewrite the inequality as an equation. And we're rewriting it as an equation because we want to solve the equation for our x-intercepts, right? That's step 1. And step 2 is to solve the equation. When we're solving the equation, we're looking for our x-intercepts. Okay? Step 3 is you can draw an entire graph, but is it necessary? No. What's necessary is to create your intervals table or to create a number line. So you either can create a table or you can create a line where you're placing those values on it. Does that make sense? So with me? All right. You're going to choose test points between those values and to see whether they are positive or negative. So with the graph, we can clearly see if it was above or below and say whether our y's are positive or negative. This time we're going to do it completely without a graph. All right, did we get our steps down? I know you're probably like, why isn't she writing the steps? They were getting there. I just wanted us to practice them, and then they were going to come out and step by step. Okay. All right, we're going to implement the steps. So making sure we're comfortable with this. So we have x squared is less than or equal to 15 minus 2x. Okay. First thing we're going to do is change this into an equation, correct? Step 1 is to turn this into an equation. So our equation would become x squared equals 15 minus 2x. And then step 2 is to solve the equation. In order to solve this equation, because it's a quadratic, I need to get it equal to 0, right? So we're going to subtract 15 and add 2x. So we're subtracting 15 and we're adding 2x. So we have x squared plus 2x minus 15 equals 0. So we're going to continue to solve this. Solving this is simple because my leading coefficient is a 1. Leading coefficient being 1, I'm asking myself what multiplies to give me negative 15, but adds to give me 2. So what two numbers multiply to give me negative 15, but add to give me 2? 5 and negative 3. So we have x plus 5, and we have x minus 3. That is a terrible 3. I don't even know what that was. X minus 3 equals 0. Okay? Now that we've done this, it makes it easier easier for us to say, okay, well, our x's have to be what? Well, x has to be, what are my x's? There we go, -5 and +3. Step 3 is now we're either going to create a table or a line, a number line. I like to do the number line, and I'll show you a model of the table in a minute, okay? So on my number line, I have -5 and I have +3. I'm going to choose values to the left and to the right and in between the two to determine whether they are positive or negative outputs, okay? So -5, I'm going to choose -6, right? Meaning that if I plug -6 back into my equation, do I get a positive or a negative answer? Okay, so I'm going to choose -6 because -6 is here. I'm going to choose 0 because anytime I can choose 0, guess what I'm going to do? Choose 0. Okay, and then I'm going to choose to 3. I'm going to choose 4. Personally, I like to start with 0 because if I start with 0, the rest is going to fall into place. Does that make sense? So if I choose 0 and I plug 0, you're plugging it back into step 2. Okay. So when I plug this in, everything with an X is going to become a 0, 0. And I'm just left with what? -15. So that means the Y values between -5 and 3 are going to be negative Ys. Does that make sense? And because this is a graph of a parabola, if my middle are negative Ys, what does that make my outside? Positive Ys. Because otherwise, would I make that U shape? I wouldn't, because I have 2 x-intercepts. The only way that it would all be negative or all be positive is if that I only had one possible solution, right? I'm only at that vertex. Okay, so we're looking here, boom, boom, boom. That part is done. How do you feel about creating a line chart? Good. All right, so step 4 is to now solve the inequality. Okay, so our inequality started off as x squared less than or equal to 15 minus 2x. We moved everything to the left. So we replaced our inequality with an equal sign. We're now going to put our inequality back. So our inequality is x squared plus 2x minus 15 is less than or equal to 0. So if I'm looking for less than or equal to 0, what type of values am I looking for? Negative. So when do I get negative y's? There we go. So we are looking for negative y's, and our negative y values are between -5 and 3. So therefore, our solution, and remember, it's equal to, so it'll be bracket -5 to 3, close bracket. Because the equal to says I also can be 0, right? I'm not strictly less than 0. I can also be 0. So that would be my solution as an inequality, as an interval notation. As an inequality, I'm saying that x is less than or equal to 3, but greater than or equal to -5. And that would be my inequality. Okay. All right. If you're a person who needs to like see the math all the way through, this is what doing it as a table would benefit you. So from the table perspective, you know that you have your -5 and 3 are your x-intercepts, right? And to the left, that's -∞ to -5. Our test value is -6. And you can go in and plug in -6 to see that the outcome is a positive, right? And then between -5 and 3, again, anytime I can choose 0, I'm going to choose 0. When we plug in 0, our outcome was -15. So that means all the values between -5 and 3 are going to have a negative output, right? Then from 3 to infinity, we have 4. We substitute 4 in, do the math, and we end up with a +9. that means that the output is going to also be all positives. Okay, so this would be, if you need to see and do the whole math, that's where the table option comes into play as well. Okay, so if the line doesn't work for you and finding the x-intercepts and just finding your middle first and then going from there, then the other option would be to create the table and fill in the values. Okay, all right, questions about 3.4?